All right, let's jump right in. We're going to tackle a question today that sounds super simple on the surface, but, well, it gets incredibly deep, incredibly fast.
I mean, really think about it. Forget skin, forget bones, all the obvious stuff. What are you really fundamentally made of? What's the stuff that makes you you?
Okay, so your first thought might be, well, I'm made of organs and tissues and cells, right? And yeah, you're totally correct. We are these amazing, complex biological machines. But that's just scratching the surface. Let's go deeper. I mean, way deeper. What happens if we zoom in past the cells, past the molecules, all the way down to the most basic, fundamental level there is? What are we going to find down there? You find this number. It's about 7 octillion atoms. That's a 7 followed by, get this, 27 zeros. It's just an impossibly huge number of these tiny, non-living bits of stuff that somehow arranged themselves into you. So yeah, if we want to understand ourselves, we've got to understand these things first. Okay, so a 7 with 27 zeros? Where did all those atoms even come from? To figure that out, we have to start with the absolute basics, the ingredients of, well, everything. And that basic stuff has a name, matter. It's pretty simple, right? Anything that takes up space and has mass. The chair you're sitting on, the air in the room, it's all just matter. So all this matter is built from a set of basic ingredients we call elements. You can think of them like the purest possible substances. Gold, for example, is an element. Carbon is an element. You just can't break them down into anything simpler using normal chemistry. And believe it or not, out of all the possible ingredients in the universe, nature really only uses about 92. Now here's where it gets wild. Out of those 92 options on the universe's menu, our bodies are almost entirely made of just 4 of them: oxygen, carbon, hydrogen, and nitrogen. That's it. That's like 96% of you. All the other stuff, the calcium for your bones, the iron for your blood, it's all crammed into that tiny little fraction that's left over. Kind of crazy, right? Okay, so we're made of elements. Got it. But what's the smallest possible bit of an element you can get? What's the smallest piece of carbon that's still, carbon? Well, that brings us to the main character of this whole story. And that hero is the atom. The atom is the absolute smallest unit of matter that still has all the properties of that element. Think about it like this. Say you have a gold coin. You slice it in half, then in half again, and you just keep slicing and slicing. The very last, tiniest little speck you could possibly get that is still, without a doubt, gold, that's one single atom of gold. But you know us, we're not going to stop there. We can zoom in even more. So what's inside the atom itself? What's the deal with this super tiny particle? Basically, you can think of an atom as having 2 main parts. Right in the middle, there's this tiny, super dense core called the nucleus. And then way, way out from there, there's this big kind of fuzzy cloud where these other particles called electrons are just zipping around. So if we look closer, we find 3 subatomic players. In that central nucleus, you've got your protons, which have a positive charge, and your neutrons, which have no charge. They're neutral. These 2 are the heavy guys. Then, orbiting way out in that cloud are the electrons, which are super lightweight and have a negative charge. And this is a really key point. Almost all the weight, all the mass of an atom is packed into that itty-bitty nucleus. And those opposite charges are what make the whole thing work. The positive protons in the center are constantly pulling on those negative electrons in the cloud, and that attraction is what holds the atom together. Now, in a normal, stable atom, you've got the exact same number of protons and electrons. So the positive charges and the negative charges perfectly cancel each other out, making the whole atom neutral. So, okay, we've got our atom. Protons, neutrons, electrons. We know the parts list. But now we get to what is, for me, the most absolutely mind-blowing part of this whole thing. Just look at this number for a second. Over 99%. What on earth could that be? Well, that's the percentage of an atom that is just empty space. Yeah, the nucleus is ridiculously small, and the electrons are orbiting in this enormous empty void. I love this analogy. If the nucleus was a marble sitting in the middle of a football stadium, the electrons would be like tiny specks flying around the cheap seats. That means that everything, me, you, this entire planet, is made of stuff that's almost entirely nothing. Which, of course, leads to a pretty obvious question, right? If you're 99% empty space, and the desk in front of you is 99% empty space, why can you hit it? Why does it feel solid? Why doesn't your hand just pass right through it like a ghost?
Well, the answer is all about electricity, or more specifically, electromagnetism. You see, those negatively charged electron clouds in the atoms of your hand get super, super close to the electron clouds in the atoms of the desk. And what happens when you try to push two negative things together? Think about magnets. They repel, they push each other away. And that incredibly powerful repulsion force, that's what your brain feels as solid. You are not actually physically touching the desk. You're feeling a force field.
So let's just wrap up with this final idea. Think about it. Every single thing you are, every thought, every memory, your consciousness itself, it's all just the result of these simple, non-living particles interacting with each other in an incredibly complex dance. We are literally built from the universe's basic stuff, just arranged in this unbelievable way. So the final question to leave you with is this. What does it mean that a bunch of non-living atoms can come together to create something so wonderfully, beautifully, and complicatedly alive?